Okay, so let's start about topic of our lecture. So today we are going to talk about steel frames. So steel frames is important part about discipline metal construction um, because steel frame is a building technique with a special skeleton frame. So of vertical columns, horizontal I-beams constructed in the rectangular grid or in other form grid to support the floors, roofs, walls of a building, so which are attached like a frame. So development of the um, frame in construction applied like for low-story buildings and so of a skyscrapers. To the skyscrapers. And we'll start from the most often type of the connections used in the frame buildings. So actually in the braced multi-story buildings, so connections may account for less than 5% of the frame weight and 30% or more of the total cost. So efficient connection will therefore have the low detailing, fabrication, erection, and labor cost. So design procedures, which we're talking about, uh, need to be actually calculated by using the special software, computer software, um, ensuring that the joint is detailed such as develops only on nominal moments which are not adversely affect the members of joint itself. So for normal design, there are many procedures checks for all parts of beam to beam, beam to column joint connection by using the special pieces for connection, angles, plates, uh, special bolted or welded angle plates. So beam-to-beam connection must be able to resist lateral forces unless the forces are resisted by other means, so within the structure, such as floor slab, for example. So shear connection. So in structural engineering, the shear connection is a joint allows for transfer the shear forces between two members, so connected members. So if the member, for instance, beam, has some internal shear forces, so this will passed on axial force into the column member. So typically shear connections act as pin. So as they don't take moment force like moment connection. Single angle connection, an example of shear connection. So the lack of welds on top and bottom of the member will not transfer moment force. So shear connection are generally the most common used connection in the construction of the by using the metal steel structures. If a frame is braced, a moment connection may not required as a bracing provide adequate lateral stability. So um, these connections can help to reduce the reliance on moment connections, so which are often more uh, complex and more costly. Um, okay, next. So the most common types are angle and plate connections. So which either use an angle bracket or plate connect the flange of the parent to web of the second member. So shear connection do not resist much moment forces as they are allowed some looseness to rotate is one of the main of differences between the shear and the moment connection. So it is was nothing that welded connection resists higher moment loads than bolted one. So there are several symbols like angle connection, single plate connection, and seated connection. So angle connection like L shape, L-shaped brackets, and it hold the parent and the additional member together. So all additional member is also called like child member. So the connection can have the either L-shaped bracket in one side or two bracket on both sides. So having double angled connections increase the rigidity of the connection. It's stronger in resisting the shear forces. So the most common configuration of two configuration of angle connection are that two sides of connection are bolted in use the bolts that reduce the cost. Single connection single connection must actually create some less rigidity than double connection. It can be bolted and welded. The additional member is welded to the parent member. As the welded to the parent, the normally is more costly to use single plate than angle connection. And seated connection. So seated connection use L-shaped bracket to connect the parent and the child member together. So, however, similar to the angle connection, they can be also welded and bolted together. So they are normally attached with a stability bracket, which is connected at the web to the flange of additional member. Okay, so if we'll talk about differences between the connection and on the previous slides we discussed about the shear connection and transfer the shear forces. So a moment connection will also transfer the moment forces. So think of it as a sort of the things that shear connection will allow rotate, but a moment connection will not. So shear connection are more common than moment connection as they are far cheaper and easy to design. So moment connection are only required when deemed absolutely necessary and sufficient lateral stability is provided in the building. So, in my opinion, this table below show us the good comparisons of shear versus the moment connections. So the most important that shear connections transfer only shear, the moment connections, the shear and moment. The shear connection uh, also can be found like a pivot or a hinge connection, a moment connection, rigid, fixed, and stiff. And about rotation from the horizontal axis, shear connection allows rotation and the moment connection doesn't allow any rotation from three axes in the construction site. Okay, so there are some examples of the moment resisting connection used in multi-story braced buildings and also in the single-story portal frame buildings. So connections in multi-story frames are mostly like to be bolted, full depths, plate connections, extended end plate connection. So where a deeper connection is required to provide a larger um, level arm for bolts, hunched connection can be also used. So the extra fabrication will result. So this situation should be um, avoided actually if it possible in the construction site. For low story buildings, for the portal frame structure, hunched moment resisting connection at the eaves and apex of frame are almost used in addition to provide increased connection. Uh, Instead of bolted to column connection, welded connection can be used in these constructions, so like portal frames. Welded beam-to-beam connection can be prepared in the fabrication shop with the bolted splice connection within the beam span or position of low bending moment. Welded connection are also used in the construction buildings with a higher dangerous situation of the seismicity. So if the building located in the seismical region. Welded connection are also used for construction with the higher lateral loads like strong winds. Um, and other types of resisting connection include the splices in columns and beams, uh, include annex connection in portal frames and the column bases. Column bases. So stabilizing the building frame. So wind loads, uh, any other horizontal loads, dynamic loads, seismical loads on acting on the multi-story building can be actually very heavy with the large wind catching areas. Such building poses in the view of wind speed um, and being the greater high above the ground. So we know that the force is increasing when the height of the building are increased. So, in addition, the large section of glass often used in the modern architecture place higher demands of stabilizing the system. And as we know, there are several mostly used types of the bracing system. It's a diagonal, moment resisting, and the shear walls. Um, let's talk about separately each of them. So, um, in general, a braced frame is a structural system commonly, very commonly used in the structures subject to lateral loads. Um, I told the wind or seismic pressure. Yes. So the members in the braced frame are generally made of steel, which actually can work effectively both like in tension and so in compression. The beams, columns, um, the frame carry the vertical loads, and the bracing system carries the lateral loads. So if there are only static loads acting from top to the bottom, maybe there are no reason to use the bracing frame. But if there are lateral loads, important of using the braced frame is higher. So the positioning of the brace, however, can be problematic as they can uh, be with the design of the facade and the position of openings. So all of them are increase some difficulty of design. So buildings adopting the high touch of modern styles have responded for the expressing bracing as internal or internal design. So the bracing frame is a commonly construction used for the some special purposes. For example, they are divided into two very, or maybe not very two variants, like vertical bracing and the horizontal bracing. So resistant of the forces provided by them, by the horizontal and by vertical. So vertical bracing between column lines in vertical planes um, provides load pass for the transfer of horizontal forces to ground level. Frame buildings require at least three planes for vertical bracing. So to brace both directions in plan and resist torsion above the vertical axis. And the horizontal bracing, the bracing at each floor in horizontal planes provides load pass for the transfers of horizontal forces um, to planes of vertical bracing. So horizontal bracing needs to need to be located at each level. So, however, the floor system itself may provide sufficiently resistance. So that's why roofs and coverings may require bracing more often than traditional floor levels. So next one is diagonal bracing. So tracing or triangulation is formed by the uh, diagonal structure members into rectangular areas of the structural frame, so helping to stabilize the frame. If a single brace is used, so it must be um, sufficiently enough to tension and to compression. Next one is cross bracing, or also known like X bracing. So used in two diagonal members crossing off each other. Um, this only need to resist the tension, or one brace in time acting to resist side forces depending um, on the direction of loading. So as a result, the steel cables can be also used for cross bracing. So however, the cross bracing on outside of face of building can interview with the positioning and the functioning of a window openings. So um, it also results of a greater bending uh, in floor beams. So K brace connect to the column at the mid height. So this frame has more flexibility for the provision of openings in the facet and results of in the least bending in floor. So car bracing is generally discouraged in the seismic regions because of the potential of the column failure in the compression break buckles. So next one, the boss of systems reduce the buckling capacity, um, like the compression brace. So in some cases less than tension yield capacity. So this means that when the braces reach their resistance capacity, the load must be instead to resist the bending of the horizontal member. So centering bracing is commonly used in the seismic regions. So it's similar to V bracing, and but bracing member do not meet at the central point. So this means that place between them at the top connection. So like you see on the picture. So the bracing members connect separate points on the horizontal beams. So this is like link between the bracing members um, that absorb the energy from the seismic activity through the plastic deformations. So eccentric single diagonals can also be used uh, to brace a frame. So steel moment resisting frames can be used for more than 100 years. So it begins used in earliest during using the steel building construction. So construction can carry the vertical loads um, for like for many story buildings and for high skyscrapers. So the frame in these structures uh, used like H shape built up from the plates, and also can be used L and Z section. So moment resistant frame, mm, it is assemblage of beams and columns um, with the beams rigidly connected to the columns. Resistance to lateral forces is provided by rigid frame connection. This is by the development of bending moments and the shear forces. So the bending rigidity and strength of the frame members, therefore the primary sources of lateral stiffness, and the strength of entire the frame. Next one is the shear wall. So shear wall for stabilization purposes can be divided into um, providing stabilization by use shear walls and providing the staffs and staircases. So the principle involved in use in staircases is relatively simple. So robust elements having uh, continuity as the stiff columns, the firmly connected to the ground and um, uh, each level by the floor. So stabilization through use the shear walls, on other hand, is less since the transmission of the forces in the shear walls. So stabilization by use the shafts will discussed briefly uh, um, and quickly. So the stiffnesses of different system might vary considerably. And the last for today is the buckling resisting brace, BRB. It is a structural brace in the building designed to allow the building withstand the cyclical lateral loads, typically earthquake loads. Um, it consists of slender steel core, concrete casting designed to continue support the core and prevent buckling and the axial compression, and brace frames have really significant advantages of vertical braced frames. So the most important thing is that it's allow the steel core resist the full axis forces developed in the bracing, so like it was designed. So the casting through its flexural rigidity provides the lateral support against the flexural buckling of the core. So the typically made of sometimes concrete filled steel tubes. The design criterion casting to provide adequate lateral resistance. So I mean rigidity against the steel core buckling. So I think that is all for today lecture. If you have maybe questions about the uh, frames, about the bracing elements, uh, actually you can ask, and I will try to repeat, maybe repeat some information or to answer some